Hello, welcome to the video for calculating work. So last class period we learned about what work was, and we have a few examples here of one where there's work being done and another where there's work not being done. So for example, let's take this first box here. We have a person who is pushing a ball, and he's pushing it with 500 newtons, and there was no movement. So we've got no movement and a force of 500 newtons. So in our example, that would have been an example of no work. Because in order for you to have work, we need a distance. And if the distance is 0, that means the work is 0. In this other example, we have a guy pushing a 100 kilogram ball with 500 newtons, but this time there is a distance of 6 meters. What these notes are going to be about, and what this video is about, is how we can calculate and find work being done. All right, so the equation for work is pretty simple. It's very much like our definition. So if we know the definition, we know the equation. So work is equal to a force times a distance. So we can write that equation in a couple different ways. We can write, instead of all of those big words, we can write W equals FD. And in this case, W is equal to work, F is equal to force, and D is equal to distance. So what I would like you to do now is copy this down under your work definition heading that you set up in your notebook, and write down the full equation with all of the words. The abbreviated version, this is the version that you will see on the test and what you will be given on your test, and also know exactly what all of those mean. So go ahead and copy that down now too. So pause your video, write this down, and then continue the video when you're done writing it down. The units for work, which is your next heading in your notes, are joules. So this is a new unit that you've never encountered before. Work is basically equal to joules, which we abbreviate as being J. Just a reminder that force is going to be measured in newtons, and our distances are going to be measured in m for meters. So again, at this point in the video, I'd like you to pause it, write that down under your heading for units for work. Okay, so here's example problem 1. Question asks, how much work is done to move a large boulder 5 meters with a force of 500 newtons? So when we solve this problem, we're going to find out that we have 500 newtons, which is equal to our force. We have 5 meters, which is equal to our distance. We want to know work. So we're going to substitute in that to the equation work is equal to force times a distance. So we get work equal to 500 newtons times 5 meters, which gives us 2,500, and our new unit that we just learned about in joules. Okay, so you have the heading of example problem 1 set up in your notes. I want you to copy down this problem, so this is another time where I want you to pause the video, copy this down, and when you're ready to move on to the next part of the video. Okay, so now that we have the very basic work equation under control, we're going to make this a little bit more complicated. When it comes to work, oftentimes work is done against gravity. So we have our situation here where we have a person carrying a box, and he or she is lifting that box up a certain distance. So that force of lifting is going to be equal to the weight of that box, which is what we started this unit off as, calculating the weight of the box. That's why we started there, because we needed to know about how much force moving that mass required. So we're going to bring back this equation. Weight is equal to mass times gravity, or big W with a little g subscript is equal to mg. You're going to see why we need a W with a g here in a second. Because we also have our work equals force times distance equation, which can also be written as big W equals F times D. So it gets a little confusing because we have two W's in equations, but the W's mean very different things. This W means weight, and this W means work. So we need to make sure that we're keeping track of which W is which. Okay, so now you have your heading in your notes of work equation with gravity. I want you to write down both of these equations and maybe take your highlighter and highlight these two with the W with gravity equals mg and work equal F times D. We're going to use both of these equations next to solve our next two example problems. Okay, so this is a falling rock problem. So in example problem number 2, it reads, what is work done by a falling rock with a weight of 200 newtons falling off a cliff 100 meters high? So we've got this clue of falling. And whenever I see this word falling, I know that I have the force of gravity working on that, which is equal to our weight. And I'll put that little g there to remind ourselves that that's actually our weight that we're going to calculate. Now let's look at our numbers though. First thing we're going to do is we're going to collect our numbers. So we've got 200 newtons and we've got 100 meters. So when we look at this, we want to think about what units do I need? So if I want to find work, I want to use work is equal to a force times a distance. Well, I already have my force because my numbers that were given to me were in newtons, and I have my distance. So I don't actually have to use both equations. I can use just this one equation. I don't need to use my work equation because I already have my force in newtons. So I'm just going to substitute. I'm going to say work is equal to 200 times 100, which is 20,000 joules. Remember, that's our new unit for work, is that big J, which stands for joules. Okay, so what I would like you to do again is pause the video and copy this down under your heading of example problem 2. And we'll continue on with example problem 3. All you have to do is unpause and watch example problem number 3. Okay, here we are at example problem number 3. This will be the last example problem that I will show you during this video. In class, what you'll be given is a set of more problems. Come back to this video, you can go back to your notes to see how they're done, and of course I will be in class to help you as you solve these problems. So what we have here is an example where we have a student lifts a 20 kilogram ball 5 meters. How much work was done? And you're given a clue here to use G is equal to 9.8 meters per second squared. So let's see how this is done. let's first collect all of our numbers. The problem gave you 9.8 meters per second squared, so that's probably a good clue that you're going to need to use it. So we have 20 kilograms, we have 5 meters, and we know that we also have 9.8 meters per second squared, which we know is equal to the little g. 5 meters, meters tells us that's a distance, and kilograms tells us that that's a mass. We have two different equations we need to use here. We need to know what the weight is due to gravity, which we also know is a force, is equal to mg. We know that work is equal to a force times a distance. Now just a little reminder, this equation is our force. So there's two steps we have to do here. First step is to find our force, because we don't know it. It wasn't given to us in our problem. Once we have that, we can plug it into this equation. So it's a two-step problem. So let's figure out what our first step, which is going to find our weight due to gravity, which is going to be the mass, which is 20 kilograms, multiplied by our gravity, which is 9.8 meters per second squared. Okay, and that's equal to 196 newtons. Okay, so now what I can do is do my second step. In my second step, I'm going to be using this equation here. The work is equal to force times the distance. I'm going to get my force from what I just calculated. So when I do my substitution, I'm going to have work is equal to 196 times 5 meters. And I'm getting that 5 meters from my distance when I collected my numbers that I already know. When I do that calculation, I get the answer of 980. And think about it for a second. What's our unit going to be? Yep, our new unit of joules. So here's our final answer, 980 joules. This is the last problem, so go ahead and pause this at this point. Copy this down for your example number 3, and I look forward to helping you in class with these type of problems when we learn to practice calculating work.